Okay, let's look at the level winder itself. We've got this set up here. We have a temporary framework, as you can see. We have a winch set up behind the level winder, but this winch actually is not the same width, so we have a temporary frame for mounting. You will take your existing lift eyes off the winch frame, and then those same bolt patterns for the lift eyes will directly accommodate these two columns. And if we look a little bit here on this side, you'll see that these columns have a bracket that's slotted in two different directions. And what this will allow is the rail itself can be raised up and down. And then this pattern here that you see will allow it to tilt in addition. So this would give you the best coupling between this surface right here and the flexible as it rolls down. Okay, so on the rail itself, this is a rectangular cross section, and we have some openings in the bottom for access, as well as 3 drain holes to allow any condensation moisture buildup to drain out. This gear is stainless steel and does not need lubrication. The gear for the carriage itself, which is on the other side, we'll take a look at that, will require lubrication. So let's look back at this overall structure. We have a bumper, and this bumper can be removed, reconfigured as needed in the future. This is designed to be able to take an in-fitting and let it hop over the top of this carriage surface here. This roller, these are UHMW rollers that can take up a lot of abuse, and currently we have rollers that are in a retracted position. The deployed position will show momentarily, but the motor itself is mounted on the carriage, so it tracks back and forth. And we have 2 hydraulic hoses for controlling the level winder cylinders. And the motor actually also comes with a encoder, which is tucked up on the inside of the shroud. So the cable carrier, a little plastic caterpillar track, is used to hold all those hoses and create a repeatable lay pattern for those lines. And this cage here is galvanized steel, and it's bolted to either end of the level winder itself to just keep things contained. All right, looking at the back side here, we'll start again at the upper area. This is the rear of the bumper. So this bumper is bolted on. You have access to the nuts back here. However, these nuts are welded in place, so it's not really necessary to get in here if everything's working properly. This slide is what actually creates the compressive loads on the rail itself. So tightening these bolts will increase the squeeze on the rail to give it the carriage a little tighter fit. So in order to do that, you loosen these bolts off here, tighten this till you can you get the proper squeeze, and then you can reset these bolts. And kind of stepping back a little bit, we have our primary drive gear. This is currently shown with no lubrication. This should be heavily lubricated. It's not for lubrication of the gear itself, it's for the corrosion protection. In addition, we have bolts underneath this pinion that will require corrosion protection to make sure they stay happy and healthy. So what you have here is an oil expansion reservoir for the gearbox itself. So quick review of these connections. We have 4 connections coming into the cable carrier and coming into the carriage. We have a roller engage hydraulic line, 1/4 inch. We have roller disengage hydraulic line, 1/4 inch. We have the motor power connection, and we have the encoder connection. So these 4 lines travel down the cable carrier out to the motor junction box.
Okay, here we are at the level winder motor junction box. So this is a point where the connection from the level winder VFD can terminate into, and then from this point out to the level winder motor and the level winder encoder are hardwired and don't need to be changed. So these connections come down through here, they're bound up, and we have penetrations into the Y flange here. So when you look on the inside, you have two connections that come from the outside, and then these two connections stay hardwired and are connected directly into the motor and the encoder.